Right. So we're one of the topic that you're learning about at school is angles. I've actually been teaching. I teach quite a few people from Redland Green, it seems, and I taught somebody from Redland Green in your year today, and so we did the same worksheet. Yes, so basically, working out the missing angle. Now, what I said to the other students as well is that basically this is application of knowledge. So the knowledge in this first case is that the angles around a point add up to 360 degrees. Then the application, the other knowledge is that to know that this is 90 degrees. This is a symbol for a right angle, so it's 90 degrees. So the application of that knowledge is to realize that if they all add up to 360 degrees, then you can work out y by subtracting this from 360 degrees and gives you 160. So in this one, the knowledge is 100, that angles on a straight line, add up to 180 degrees. And again, you subtract to find out the answer. The knowledge here is that angles on a right angle add up to 90 degrees. This is also the reason that you'll be given in each case. The knowledge here, you knew about the 1, 2, and A, B, and C, all of 1. But question 2, you're a little bit unsure of. But you remembered it when I pointed it out. And then we just kind of, then we got another bit of knowledge. Angles on a triangle add up to 180 degrees, and then it's just a repeat, really. Did that one quite well. I was quite pleased with that. You realise that because all three are the same, and they add up to 180, then you quickly worked out that it was going to be 60, so that was good. A repetition of the previous type of question. So I taught you something relatively new and you applied it quite quickly. Same here as well. And then this one. Now this one is, we can apply two different bits of knowledge here. So we can apply, because they've asked us for angle A first, then we can apply this bit of knowledge, that we can call them vertically opposite angles, but really that means that if you get two intersecting lines, then the opposite angles in these intersecting lines are equal to each other. But you can also use the knowledge of angles in a straight line add up to 180 degrees. And so if we take the straight line that I've highlighted green, then we can see that B must be 76 because they have to add up to 180. And then you can highlight the pink line and then and say that, well, A and B must add up to 180, so A must be 104. And from doing that, you realize that that's the same as that. And that's kind of proving that angle, so proving that statement there. So a more kind of clear proof would be something like this. And this is kind of a bit more advanced. So one of the things you may have to do later on in maths is not just to apply rules like we're doing right now, but to prove rules. So we're trying to prove that that angle is the same as this angle. So how do we do it? Well, if we say that that's A and that's B, and then we'll say that this one is C and this one is D, we're trying to prove that A is equal to B and that C is equal to D. Well, we can prove it by applying the fact that A plus C is equal to 180 degrees. We'll just say 180. Yeah. No, we'll say 180 degrees. And then that B plus C is equal to 180 degrees. And therefore, if A plus C is equal to 180 and B plus C is equal to 180, we should be able to see from there that that A and B must be identical. But if we wanted to explain it a little bit further, then we can maybe, if I just move this one down a little bit, doing a bit of algebra, I can subtract C from both sides, and I have A is equal to 180 degrees minus C, and over here I can subtract C again, and B is equal to 180 degrees minus C. Now, that's the same thing, isn't it? So if A is equal to that, and B is equal to that, then A must be the same as B. So that's a way of proving that. That's a proof. Okay, so you've got the knowledge, and then you've got the application on knowledge, and then you've got the proof of it as well. Okay. Anyway, that's what we've been doing so far. So I'll just save that video.